Hi, I'm David. Today we're going to talk about interstellar, time dilation, the differences in time, like when the man came back, Matthew McConaughey, and his daughter was an old woman. Well, let's get started. I know it's been a few years since that movie was released, but there are a number of questions that are out there floating on the internet that seem unanswered or are a little bit improperly articulated, if you will. Now, there are some very interesting things that we saw in that movie, and it was a very good movie, also very emotionally charging. At the end of the movie, they came across a 5-dimensional space when they fell into the black hole. Matthew McConaughey and his block of a robot, his Minecraft robot, if you will. When they fell in there, the idea wasn't necessarily that time was the object. It was about them detecting a point in space, and then all points in time for that point in space were present. And that's what he was traveling through. He was traveling through time through one point in space. That's the whole concept around that. So essentially, when he was going from bookshelf to bookshelf, it wasn't that he really understood where he was going, except that in 3 dimensions, they had represented time itself so that he could go forward or backward, but it was overwhelmingly large. I found it very interesting that the character, of course, conveniently knew exactly where to go to find the appropriate point in time, but yeah, like he said, they picked one point in space and then could go throughout all time for that, and present it to him in a way that was easy for him to perceive. And so therefore he was actually the ghost of his daughter. There were several times where they were talking about how much time was passing on Earth compared to where they were. One point in the movie was when they landed on the planet that was water and they were able to land on it. And you saw that huge surge or swell of water coming at them. And they were saying that every moment counted. Well, there is some real science behind that, although it might not be exactly what you think. So let's use a real-world example here. I'm going to take a black hole from this area here, which is estimated to be about 5.4 times the mass of the sun. And here's the crazy thing. For being a stellar black hole, it's only about 10 miles across. With a radius, anyways. 10 miles, that's not very big at all, but it's super heavy. It's crazy. Imagine you were in a spacecraft 8,000 kilometers above the surface of this black hole, and your buddy Bob, because everybody knows Bob, and Bob is usually a little simple, but we love you, Bob, don't worry. Simple Bob is on the surface with the event horizon of this black hole, and for every second that is experienced on this spaceship right here, almost 10 seconds occur for Bob. If we were to lower Simple Bob just a little bit deeper into the black hole, just 99.99% of his current placement on the event horizon of the black hole, we end up with him gaining about 0.06 seconds more compared to time experienced on the satellite. But if we take him down to just 99% of the event horizon where he's standing, just that tiny, tiny little fraction of 1%, the entire equation flips and it ends up becoming a negative. And to be honest with you, I can't really tell what that even means. Does time move faster inside of the black hole? Does that mean that maybe time breaks down at some point inside of the black hole? Or maybe it just speeds up, it goes faster inside of the black hole as opposed to outside. Or it could just be that our time dilation equations cannot account entirely for a black hole. At the center of every black hole is something called a singularity, which is essentially infinity. And our equations can't handle infinity, just like 0. You can't divide by 0 or multiply by 0 without getting a divide by 0 error or getting 0 as a result. Same with infinity. If you multiply by infinity, you get infinity. You divide by infinity, you get infinity. What is infinity? That's a topic of hot debate in mathematics. Well, time being fluid, traveling forward and backwards at the same time, was something predicted by Einstein. And while we are not necessarily capable of seeing it that way, maybe someday we will. Now, on the topic of time being different near the black hole and everything else, one little gripe that I have is the planet around the black hole. You would think, due to its proximity or location near that black hole, that the tidal forces or the gravity itself would tear the planet apart. It wouldn't have even been able to form, most likely. But I didn't do the math on that one because I didn't have the time. So for a rundown of time dilation equations, I'm not putting in speed time dilation. There are definitely 2 other videos that we've already done, so check those out. They should be somewhere on the screen. Another thing that I found really interesting was the stasis, or the human stasis, or sleep, if you will. Something like hypersleep, which has been a concept in science fiction for quite a long time. And there's actually some science behind that. So there was a technological breakthrough quite a few years ago where they were able to suspend the animations of the body and slow everything down so that somebody could potentially be in a resting state or position for an extended period of time, but it hasn't been tested yet for something as long as a Mars flight, which can be 6 months long, depending on the launch itself, or it could be as long as 2 years, depending on when they launch it, when the Earth and the other planet, they don't really have a good window of opportunity at that time. When it comes to technology like that, it's not so far-fetched. It's actually quite interesting, and I'd recommend checking that out. A couple of things that I found ridiculous about the film was the fact that they were using general propulsion to reach interstellar destinations. Now, while they had an excellent drive system and everything else, traveling at those speeds for that amount of time, the human body, even in a stasis chamber, is going to probably degrade significantly. Another thing I found ridiculous is who's going to leave Matt Damon on a frozen wasteland? Really? And lastly, like I said before, that planet in orbit around the black hole would probably not have even been formed. But otherwise, the story was well written, it was well derived, the character development was fantastic, and it definitely brought a tear to everybody who has a family. So, all in all, very good movie. Of course, some of the premises, like the 5th dimension at the end of the movie, are very likely very, very far-fetched, but in general, I'd still give it a 7.5 or an 8 out of 10. That's my opinion. What's yours? Don't forget to subscribe, check out other videos, like, share, and hit that bell for notifications for future videos. And we'll see you next time.